Welcome to Third Angle, and we're getting in the driving seat, but where we're going, we don't need roads. I'm your host, Paul Haimes from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. There was a time when you were most likely to come across a driving simulator in an arcade or at a theme park. But in recent years, the world's top automotive manufacturers and racing teams have been increasingly relying on them to train drivers, as well as enhance ride experience in the car design process. The simulators that Dynisma have built are so advanced and have pushed the boundaries of driving simulation so much that more traditional simulators just don't cut it anymore. It's all to do with an obsessive attention to detail, engineering and experience so that the human body and the human mind find it very difficult to tell the difference from the real thing. For Formula One drivers, for instance, every split second counts, and so by reducing the latency of the simulator to just a few milliseconds, they can perfect their reaction speeds and assess the impact of upgrades to keep one step ahead of the competition. And this is just one of the ways in which Dynisma are changing the face of simulation and have no doubt helped some of the biggest names in motor racing onto the podium. Now, as a huge motor racing fan, I couldn't pass up the opportunity to try out one of Dynisma's simulators myself. So I went along to their HQ in Somerset to meet Ash Warne, founder, CEO, and chief engineer, and of course, put my driving skills to the test. Well, I've just stepped into Dynisma just outside Bristol, and I'm here today now to have a go in their 9 degree of freedom motion simulator. And with me today is Ash Warne, who looks after the setup here. So he's going to be my tutor and my guide and hopefully keep me out of the barriers.
Okay, Paul, so here we are. This is DMG1. This is our demonstrator. We're going to give you an experience of a motorsport scenario today. So we've got an F1 car model and we're going to send you to Spa. We've got Tom Canning here and he should be able to talk you around the track, the gears, etc., get you up to speed quickly. And what we're really looking for here is for you to be able to feel some of the unique capabilities of this system, in particular the bandwidth, the latency, how you can really feel what the car is doing and how quickly the simulator is able to provide that feedback to you, such as, for example, if you get the back end stepping out, you're really able to feel that immediately and respond to it and catch the slide, whereas in other simulators you might just spin out.
I don't suppose you haven't got a Formula 3 model here, have you?
A Formula 3 model?
Yeah, I don't know, I'm just asking, it's just that I used to drive Dalara's years ago, and so that's probably closer, but I mean, not that it really makes any difference.
You'll get up to speed very quickly, I'm sure. You just brake a bit later, go a bit faster.
Okay.
Yeah.
The general ingredients of it.
Just the left and go flat out. Really good. So now remember, it's flat out all the way until the last chicane.
Got it.
So Dynisma develops driving simulators for automotive and motorsport markets. So a driving simulator is a tool that is used predominantly to develop a car, whether that's a road car or a race car. And ultimately what we're trying to do is to recreate the experience of being in a real car as accurately as possible. But critically, a simulator is able to adapt. So 1 minute or in one incarnation, it could be an SUV, then it could be an EV, then it could be a saloon, and then it can be a race car. So it's important in driving simulation to be able to evaluate different setups. And this is ultimately what their value is, to be able to try things out without having to go and build the physical thing and build a prototype. You're able to take an idea directly from a piece of paper into a mathematical model that encapsulates what's going on and put it in the simulator, and the driver can drive it, or in an autonomous vehicle scenario, perhaps just experience it and provide feedback to the developer, whether they be an automotive manufacturer or a motorsport company. And of course, as well, the environment is all simulated, so you can quickly go from the glamorous location of driving around Monaco to being stuck in traffic on the M40. So what really drove me to leave the world of F1 and set up my own business was really the desire to create something. You know, I had many ideas. I could visualize what was possible, but wasn't always able to go and do that within the confines of a large business, of a team, for example. So yeah, I struck out in 2017 and founded Dynisma. Had a vision of what should be possible in terms of the capabilities of the technology that weren't there and weren't being offered by competing products at the moment. So I set about modelling, designing, and within a year had come up with a prototype that demonstrated all of the unique capabilities that we still see in our products today.
So the first one's going to be second gear. Well held. I'm Tom Canning. I'm a racing driver for Aston Martin, and I work with Dynisma on the sim model, like the car model development side. And I was just working with Paul then, talking around the lap around Spa in the Formula One car. Through my racing, I drive on quite a lot of simulators, and there's nothing really else out there that compares to this. Yeah, you just get so much feeling through your backside. It's the closest to real life you can get without actually going out on track in a car.
Okay, Paul, how did that feel?
It felt amazing. It felt awesome. Ultra realistic. And then the actual way the back of the car starts to move and step out and the loading on the curbs. Yeah, fantastic. Really, really, really realistic stuff. So brilliant. Thank you.
Yeah, I saw you catch some oversteer, some slides. You were really dialed in there.
So just to explain to our listeners what we're actually looking at here at Dynisma with the demonstrator, we've got what is a regular racing car monocoque that is supported on 6 arms and gives it the 6 degrees of freedom that you require. But then that is in turn mounted on a table, a plinth, which is also able to move in 3 degrees of freedom, and that gives you the 9 degrees of freedom total there. And then wrapped around that, we've got a huge screen with 5 projectors projecting then the full field of view for the driver in fantastic sort of reality in terms of the detail that you're looking at, not just of the scenery and everything else, but the inside of the vehicle that we're driving as well. So there is a huge amount going on here. It's a very, very complex environment, but all comes together to provide an unbelievably realistic driving experience.
I think that's one of the really unique things about driving simulators that you just touched on there, is the fact that they are firstly very complex systems. So there are tens of computers and CPUs and graphics cards all working together to produce this cohesive simulated environment. But it's also the sheer number of cues and stimuli that we're providing. You know, the idea here is to convince probably the most complex thing in the universe, i.e. the human, that they're engaged in some other activity, and they're doing that in a very serious fashion and giving accurate feedback to steer the development of road cars and race cars. So it's important that we model what the person sees, what they feel, and what they hear as well. Our unique selling points really focus on the high bandwidth and the low latency and the smoothness of our simulators. And these correspond basically to, first of all, bandwidth. It's the amount of information that you can get through the system. So if the analogy was television, then we're 8K, whereas other simulators are standard definition. It's about putting higher fidelity, higher frequencies through the motion generator, as we call it, to put some numbers on it. Many of our competitors have a bandwidth of 20 hertz, whereas we are 50 and even in excess of 100 hertz on different systems. And what this means is that vibrations, movements that you feel in a real car are able to be accurately transmitted through our motion generator and therefore given to the participant in the simulator study using a Dynisma simulator. Whereas in other simulators, they tend to feel muffled, filtered. You miss some of the sort of harshness that you can get in reality and the higher frequencies, including vibration and noise. The second USP is low latency. So we have a latency of between 3 and 5 milliseconds. So what this means is that within 3 to 5 milliseconds of the vehicle model calculating that some movement needs to be transmitted to the driver, we can measure using an accelerometer on our motion platform that movement has happened. So this is, again, an order of magnitude better than many of our competitors, and it's in the motorsport example is really what sets us apart, because it allows the driver to drive the car on the limit as they're able to in reality, whereas in other simulators you find that if you try to correlate the balance of the car, i.e. how understeery or oversteery it is, you end up with a car that, its back end slides out but you can't catch it because the simulator doesn't respond quickly enough, and therefore the driver gets the cue to correct too late. They've already spun out. So what you tend to find in other simulators is that you lose correlation because you have to dial understeer into the balance of the car just to get it around the lap. Whereas in our simulator, we're able to have a very unstable, oversteery car balance where the driver is soaring at the wheel, keeping it in a straight line as they're braking and turning and sliding into the corner. This is something you can't do in other simulators. The final USP that I've mentioned is just the smoothness of our motion systems. Drivers have described it as feeling a lot more like the real car, and that's there's no mistake really. We took design cues from how vehicle suspension worked in developing our motion simulators, whereas typically other technologies are based on perhaps flight simulators where high frequency really isn't as important as it is in a ground-based vehicle.
So Ash, tell me a little bit about the head-mounted display and how that enables you to offer the mixed reality environment for the simulator.
Yeah, sure. So obviously, Paul, what you've just driven there is the projector-based visuals. So this is very sort of typically how it's been done in driving simulators for a long time. What we've been able to do is implement a Vario head-mounted display in our simulator, and this replaces the projectors. This allows you to feel a far greater sense of immersion. You can see your hands in the mixed reality context. You can see the steering wheel in front of you, and yet that's augmented with the graphical environment around you. I think uniquely what we've been able to do is to get the system working in a motion simulator. So despite the fact that the chassis is moving and shaking around to provide you all of those cues of what the vehicle is doing, we're still able to keep track of where the headset is and correctly present to you both the graphical world and the real world within the cockpit.
Up to fourth and then just a small left. That's really good. Third gear down the hill.
So Ash, we're now here at Dynisma's manufacturing site. So we're just stepping into what is one of the larger units here where all the engineering takes place and so forth. So if we just step inside and then we can get started having a look around.
So the guys are just building up the ground system here. This is really important part of the load transfer to ground. So our systems are very responsive, high bandwidth as I've mentioned, and this requires a great deal of stiffness. So hence you can see some really solid structures here.
The sort of strength and the size and the weight of this chassis, I guess, is all part of making sure that nothing moves that shouldn't move. That's what we say.
Yeah, and in simulator parlance, that nothing moves that shouldn't move would be eliminating miscues. So, we're in the business of creating cues, feelings for the driver or for the passenger that correspond to the situation that you're trying to simulate. And what we're doing, and I think what we specialise in, and I think we do better than our competitors, is eliminating those miscues, the bangs, cracks, whistles and grinds that often appear on other simulators.
We should also touch on sustainability and the fact that what we're doing with simulation means less models are being used, less materials are being used, less manufacturing time, less greenhouse gas. This is all part of a more sustainable future for manufacturers in all industries.
Absolutely, yeah. So more simulation means fewer prototypes, it means fewer prototype miles. The more that can be done virtually, the fewer emissions are being generated. One of the big contributors is having to take prototypes all over the world in order to test them in different environments. And the more that can be virtualized and simulated offline, the fewer cars, prototypes, mule cars there are shipping around the world to all of these extreme environments, for example.
That was Ash Warne, founder, CEO and chief engineer at Dynisma. Now, the team there use technology, physics and engineering and fine-tune it to work in harmony with the human body so that the motion cues are perfectly aligned to the vision, the sound and the feeling from the simulator. One of the tools that help them to do this is PTC's cloud-native design and PLM solutions OnShape and Arena Connected. Time to meet our expert, PTC's EVP John Herstick, who can tell us more. Now, John, I was fortunate to spend time at Dynisma, and the first thing that struck me was the sheer size of the simulators on offer. Now, I've seen a number of simulators offering the 9 degrees of freedom movement, which is typical today, but never one that was capable of carrying such a high payload, anything up to 750 kilograms. And this means that they can simulate the whole vehicle cabin with multiple participants, not just the single driver monocoque that we often see with the racing simulators. Now, because of that, the Dynisma offering is in high demand, not just from the world of motorsport, but also some of the world's biggest car makers who are now keen to use the simulators to test drive concept cars before they enter production. Now, they needed a design and a PLM solution that could scale up quickly and were compelled to switch to PTC's cloud-native Onshape and Arena Connected. Now, John, are you able to give an overview of what that means from a solution perspective and how Dynisma can capitalize on it?
Happy to. Onshape and Arena together provide unique value to Dynisma and many other companies around the world because we are the only cloud-native CAD, PDM, and PLM solution in the world. And what this means is we help companies deploy agile process to design, test, produce, manufacture products on a faster, more agile basis than they could ever do before Onshape and Arena. And it comes from several key aspects of the unique cloud-native Onshape and Arena CAD, PDM, PLM solution. First, they're connected in the cloud. This means that our connection will synchronize the CAD, PDM, and PLM across engineers, manufacturers, suppliers, instantaneous sharing of product design information so that there's essentially a global, real-time, single source of truth. All your internal teams, your manufacturing partners, perfectly in sync. And when it comes time to add a new partner, that happens instantly. Much like the responsiveness of the Dynisma simulator, which I understand is amazing because it's down to milliseconds. When you're adding a new supplier or a new team member with Arena PLM, you don't have to wait hours or days for them to be onboarded and installed. And what hardware do you have? You click a few buttons, instant access through the cloud. We see collaboration being vital. It's the name of the game in today's world of modern product development. It's vital to Dynisma. They're designers and engineers. They need to be able to see what each other are doing, to run through different ideas, tweak them in real time so they can see in moments what the other team members are working on. Being in the cloud, not just in the cloud or using the cloud, but cloud native means that everyone involved can get the information they need anywhere in the world, extremely efficient way of logging any changes. Dynisma, they're pushing the boundaries of innovation in terms of simulators and to achieve their level of performance, the level of state-of-the-art, down to the millisecond, Formula One, we feel they need the state-of-the-art, high-performance CAD, PDM, and PLM that Arena and Onshape offer. We're a SaaS, cloud-native design, development, manufacturing, supply chain platform. We're robust, we're usable out of the box, but you can tailor us to meet specific requirements very easily. And when you make modifications, everyone in the world, as you customize your system, you're not worried about upgrading and admins and all that happens instantly for everyone around the globe. So we're super excited to be part of the Dynisma story in this stage of growth. I'm jealous that you got a chance to try out the simulator. I'm hoping I get to do it myself. And I think that I really see an exciting analog between Dynisma simulating the twists and turns of modern racing at the highest possible speed and Arena and Onshape giving them the PLM, CAD, and PDM tools so their team can work at the highest possible speed and take the turns fast, to come up in product development. So delighted to have Dynisma as a customer of Cloud Native Arena and Onshape from PTC.
Huge thanks to Ash for showing us around their facility and helping make my dream of driving the Spa circuit in an F1 car virtually come true. and to John for helping us to understand the deployment of Onshape and Arena Connected. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook, sound design and editing by Ollie Guillou, recording by Clarissa Maycock, and music by Rowan Bishop.